So here we've got two chords intersecting in a circle. One chord I'm tracing out with my pen goes from the upper left to the lower right, and then there's the chord that has a segment of 3 and a segment of length 6. We need to solve for x. We're going to draw this again, and we've got a center, which is C. We've got a chord here that's 3 and 6. We've got a piece here that's x, and we've got a radius that is length 5.5. So we know this other radius also must be 5.5. And as we've done before, we know that this distance from here to here has to be 5.5 since it's a radius minus the x that is already there. So this is 5.5 minus x, and we can go ahead and we can make a product of the two chords. This is the intersection point. It's 3 times 6, the two pieces of the chord, the first chord, and then the pieces of the second chord would be x, which is to the left of that intersection, times this length, which is 5.5 minus x plus 5.5. And so what we need to do is we need to combine like terms, solve for x. 6, 12, 18 on the left. Let's combine like terms. 5.5 times 5.5 is 11 minus x. So that's our new equation. Let's multiply and distribute x over 11 minus x. That gives us 11x minus x squared. But you all know I like to have a positive x squared, so I'm going to add x squared to both sides here. That's going to give me 18 plus x squared on the left, and the x minus x squared cancels out, which just leaves me with 11x on the right. I'm almost done. I want to set it equal to 0. I've got the x squared that I want on the left, so I'm going to subtract the 11x from both sides, which is going to give me x squared minus 11x plus 18 on the left equals to 0. I like to write quadratic equations so that they go in descending powers. So I have x squared here first, then I have the x, and then I have the constant term there. Question is, can we factor this? Do we have an x, and then a number we can place in this positions so that they multiply together to give a positive 18, but they add together to give a negative 11? Well, two numbers that, first of all, there's got to be a negative in there somewhere because we've got a negative here. And if they multiply to give a positive, they both must be negative, which means that the absolute values of the two factors must add up to 11. So let's start listing the factors of 18 and see whether we can come across two that add up to 11. There's 118, was 2 times 9, and we're done. 2 times 9 is 18, but 2 plus 9 is 11. And if they were both negative, the product would still be positive 18, and the sum would be negative 11. So we've got negative 2, negative 9, and you could, if you like, FOIL this, check it, make sure that it works. It will work. The roots, the answers, the solutions we get by setting each one of these factors equal to 0. That gives me x equals 2 for one of them, and x equals 9 for the other one. These are the two possible solutions. Well, let's see what makes sense. 2 seems to work out okay. That would make this 2, that would make this 3.5. So that would work out. But 9 would not work out. 5.5 minus 9 here would give us a negative value. So it cannot be 9. 9 cannot be a solution. The solution is 2. So that means the final circle looks like this. We still have the 3 and the 6 over here. And what we've got here is x is 2. And then we've got 5.5 minus 2, which is 3.5, plus 5.5 on this side, which is a total of 9. So to keep things simple, the other piece of this chord is just 9. Does this work? Is 3 times 6 equal to 2 times 9? Yes. So therefore, we found the correct solution. The next video, we'll move on to number 4.